Hello, in this lesson we will learn about inverse trigonometric ratios. So the learning goal is to learn about the inverse trigonometric ratios, specifically the inverse sine, the inverse cosine, and the inverse tangent. So to illustrate the inverse trigonometric ratios, first we will review some basic concepts we learned in the previous lesson called trigonometric ratios. Here we have a right triangle. The opposite to the 90-degree angle is the hypotenuse. Alpha here will be our reference angle that determines which is the opposite side and which is the adjacent side. So sine of alpha would be the opposite side length divided by the hypotenuse. Cosine of alpha would be the adjacent side length divided by the hypotenuse length. And the tangent alpha would be the opposite side length divided by the adjacent side length. Okay, all of these are lengths of the sides of this triangle. Now, sine inverse of opposite side over hypotenuse will give you alpha. Okay, so to use the inverse, all you do is swap these two arguments, right? The alpha will move to the right and this fraction will move to the left. And then you put this -1 to indicate the inverse. So sine inverse of this fraction will give you alpha. Likewise, cosine inverse of the adjacent side over the hypotenuse fraction will give you alpha. And tangent inverse of the opposite side over the adjacent side will also give you alpha. Let's illustrate this further. Sine of alpha equals A. So sine inverse of A will equal alpha. Okay, again, all you do is swap these two values, the alpha to the right and the A to the left, and you put a -1 here. Okay, that's one way to remember this. Let's check a numeric example. Sine of 30 degrees equals 1/2. So sine inverse of 1/2 equals 30 degrees. Cosine of alpha B equals B. So cosine inverse of B will equal alpha. As a numeric example, cosine of 60 degrees equals 1/2. So cosine inverse of 1/2 will equal 60 degrees. Finally, tangent of alpha equals C. So tangent inverse of C will equal alpha. Again, alpha and C alpha represents any angle you want and C represents any number you want. Now, tangent of 45 degrees equals 1. So tangent inverse of 1 will equal 45 degrees. Okay, now let's go into some more concepts. Sometimes these inverse functions are known with a different name. So the sine inverse is also called arcsine. And in the calculators, you can see these symbols, arcsine, like this, or a sine. So these are abbreviations of arcsine, which are basically the same as sine inverse. The cosine inverse is also called arccosine, and these are the abbreviations that you can see in your calculator. And finally, the tangent inverse is also called arctangent, and these two are the abbreviations you may see in your calculator. Okay, let's go into practice problems. In this problem, we need to find angle A. Okay, so every time you are looking for an angle, you have to think of the trigonometric inverse functions. Okay, so this is the angle we need to find, A. what we have is the adjacent side to A, which is the square root of 2, and the hypotenuse, which is 2. So what trigonometric function or trigonometric ratio links those two? That would be the cosine. Cosine of A would be adjacent side over hypotenuse, which is a square root of 2 divided by 2. Okay, so again, you analyze what they give you. If they give you the adjacent and the hypotenuse, you have to use cosine of the angle. If they give you opposite and hypotenuse, you will use sine. If they give you opposite and adjacent, you will use tangent. Depends on what information the problem gives you, you decide which of the three trigonometric functions you need to use. In this case, it's the cosine, because it's the adjacent and the hypotenuse that they provide you. Okay, so we say, okay, cosine of A equals the square root of 2 divided by 2. That's what we have. Now, if we want to find the angle, we use the inverse function. Cosine inverse of a square root of 2 over 2 will give you A. Again, you swap these two arguments and you put a -1, and that will give you the structure or the equation that you want to use in your calculator. So all we need to do is to put this in our calculator. I prefer to use Desmos for this purpose. Okay, so this is the Desmos calculator. Now I'm going to type there. I'm going to click here. Let me just move it like this. Okay. So I'm going to click here, first of all, in these settings, and make sure that the angle is in degrees, not in radians. That's very important. Now, after that, I'm going to type or click here, click functions, and choose the cosine inverse, which is here. So I click that, cosine inverse, and I type square root of 2 divided, sorry, let me just go back. Square root of 2, I click a space to the right, and then divided by 2. And the answer would be 45 degrees. Okay? Again, I type this function here in Desmos, and the answer is 45 degrees. Okay, so we finished this first problem. Let's go into the second practice problem. They say a 250-foot tall building casts a 450-foot shadow. What's the angle that the sun hits the building? So that's the building, which is 250 foot tall. That's the sun. That's the sun ray. And this is the shadow, which is 450 foot in length. Now, the angle that we need to find is this angle. And again, we have to see if this is the reference angle, okay? Let's call that X. So what information do we have to find the angle? We have the opposite side and the adjacent side. So I will use the tangent function because that links opposite and adjacent. So the tangent of X links opposite side and adjacent side, and that's what I will use. So the tangent of X will be 450 divided by 250, okay? So now I'm going to use my inverse function. Again, we swap these two and we put a -1. So tangent inverse of 450 divided by 250 will equal X. And that's what I need to put in my calculator. Okay, so I'm here in the calculator. I already checked that the angle is in degrees. Now I click here, I go to, again, if this is minimized, you have to click this keyword to maximize it. you click in functions and you click tangent inverse. And you type 450 divided by 250. And that's it. That gives you the answer, which would be around approximately 60.9, which let's say 61 degrees. And we finished. Thank you very much for your attention.